Okay, so the next thing that we have here is a couple of exercises to basically about limits. And suppose that, for example, you want to evaluate the limit of x plus 3 when x tends to 3. So the limit of x plus 3 when x tends to 3 is just basically x plus 3 is just a polynomial. So you can write this as, and you know that the limit of f of x when x tends to a, when f of x is a polynomial, is just f of a. So that means that basically then you can write this as 3 plus 3, which is equal to 6. And of course this is the value of the function. This is the value of the function f of x is equal to x plus 3 at, this is the value of f of x at x is equal to 3, meaning that x plus 3 is basically this function over here, and you get basically this function over here. So this is the value of f, this is the function f of x is equal to x plus 3. Now the value of this function at x is equal to 3 is basically this point over here, which is supposed to be basically this point 3, 4, 5, and 6. So this is actually the expected value of, so then you can say that the limit of x plus 3, or if you call this, for example, if you call this the limit of f of x at x is equal to 3 is equal to the limit of x plus 3 at x when x tends to 3 is equal to 6, which is the expected value of the function at x is equal to 3. So that's basically that. Now suppose that, for example, you have for example the limit of x minus 22/7 when x tends to pi, for example. Now if I can take pi as 22/7. I can write this as basically I can write this as 22/7 minus 22/7, which is equal to 0. Or they have written this as basically, the way that they have solved the problem, they have written this as the limit of x minus 22/7 as x tends to pi. They have written this as pi minus 22/7. Of course, when you take pi as 22/7, then it's going to be equal to 0. Otherwise, it's going to be pi minus 22/7. Now suppose that you have the limit of pi r squared. You have the limit of pi r squared when r tends to 1. So again, you can evaluate this function at r is equal to 1, which would be pi times 1 squared, which is equal to pi. Which is equal to pi. Number 4, you have the limit of 4x plus 3. You have the limit of 4x plus 3 over x minus 2 as x tends to 4. Okay, so if I can write this as basically 4 times 4 plus 3 over 4 minus 2, which is equal to 19 by 2. So simply finding the value of the function at this point. Number 5, if you write the limit of x raised to the power 10 plus x raised to the power 5 plus 1 over x minus 1 when x tends to negative 1. Now when x tends to negative 1, you can write this as negative 1 raised to the power 10 plus negative 1 raised to the power 5 plus 5 over negative 1 minus 1, which is equal to 1 plus negative 1 plus 5 over negative 2. These two will cancel out and you have 5 over negative 2. I'm sorry, this is a 1. This is a 1, and so you would get negative 1 by 2. Negative 1 by 2. Okay, so the next one is, for example, you want to calculate the limit of x plus 1 all raised to the power 5 minus 1 over x when x tends to 0. So you will have basically 0 plus 1 all raised to the power 5 minus 1 over 0, which is equal to 1 minus 1 over 0, which is equal to 0 over 0. So 0 over 0, that means that we could probably somehow take an x out from the numerator. And simplify this. And x plus 1 raised to the power 5 minus 1, you can simplify it as, so basically first you need to rewrite this first part. So x plus 1 raised to the power 5 minus 1 So you can write this as, for example, x plus 1 raised to the power 2 times x plus 1 raised to the power 2 times x plus 1. And then this is x squared plus 2x plus 2. And then this is x squared plus 2x plus 2. And this is x plus 1. I'm not sure if this is the best way to solve this problem, so let me check. Well, as I mentioned, this is actually not the best way to solve this problem. So usually there is a point in these exercises. And the point is usually not to do so much of calculation. So what you need to do here, basically we said that the limit of x raised to the power n minus a raised to the power n over x minus a when x tends to a is equal to n times a raised to the power n minus 1. So this is what we had. So now what we can do, we can rewrite this limit as the limit, meaning that we can take x plus 1. Basically we can put x plus 1 is equal to y. So if x plus 1 is equal to y, then I can write this as the limit of basically y raised to the power 5 minus 1 over, and then x becomes, and then over here x becomes y minus 1. Now as x tends to 0, then y tends to 1. As you can see here, as x tends to 0, y tends to 1. So then I can write this as the limit of y raised to the power 5 minus 1 over y minus 1 as y tends to 1. And then this is, and of course I can write this as 1 raised to the power 5, which is the same thing as 1. And so now this is the same form as this. So I can write it as n times a, which is 1 raised to the power n minus 1 raised to the power 4, which is equal to 5. So that means that the limit of x plus that means that the limit of x plus 1 raised to the power 5 minus 1 over x when x tends to 0 is equal to 5. Okay, so the next question is question number 7. Which is the limit of 3x squared minus x minus 10 over x squared minus 4 when x tends to 2. So So this is equal to 3 times 2 squared is equal to 4 minus 2 minus 10 over 4 minus 4, which is equal to 12 minus 2 minus 10 over 0, which is equal to 0 over 0. So you need to now somehow factorize basically the numerator and denominator. So basically you have 3x squared minus x minus 10 in the numerator. So if you multiply negative 10 by 3, you will get negative 30. And negative 30 can be written as, or basically 30 can be written as 1 times 30 or 2 times 15. This is 3 times 5. So you can go for 6 and 5, meaning that 6 times 5 is equal to 30. So you can say that 30 is equal to 6 times 5. Now, if I take 6 and 5 and make this negative 6 and make this positive 5, then negative 6 times positive 5 is equal to negative 30, which is basically the same thing as 3 times negative 10. So that's taken care of. And then negative 6 plus 5 is equal to negative 1, which is this number. So now I can use these two numbers in order to rewrite this middle term over here. So I'm going to rewrite this as 3x squared minus 6x plus 5x minus 10. And so I can take a 3x out from these two terms, and then that gives me x minus 2. 5 I can take out and write it as 5 times x minus 2. And so that is 3x plus 5 times x minus 2. So I can write the numerator, the limit of 3x plus 5 times x minus 2. And this over here, x squared minus 4, I can write it as x squared minus 2 squared, which is the same thing as a squared minus b squared, which is a minus b times a plus b. So I can write this as x minus 2 times x plus 2. So I can write this as x minus 2 times x plus 2. And now when x tends to 2, now I can cancel these two factors out from the numerator and the denominator, since x is not equal to 2. Since x is not equal to 2, we can cancel out, x minus 2 from the numerator and denominator. Otherwise, it would not be allowed. It would not be allowed. So now I can write this as the limit of 3x plus 5 over x plus 2 as x tends to 2, which is equal to basically 3 times 2 plus 5 over 2 plus 2, which is equal to 11 over 4. So number 7 is 11 over 4. Okay. Okay, so the next question that we have is we want to find the limit of x raised to the power 4 minus 81 over 2x squared minus 5x minus 3 as x tends to 3. So if you find that the value of this rational function at this point, you would get 3 raised to the power 4 is equal to 81 minus 81, which is equal to 0. And then you have 2 times 9. 2 times 9 minus 5 times 3 minus 3. This is 1. And that is equal to 0 over, this is 18 minus 15 minus 3. This is 0. This is 0 over 0. This would be 0 over 0. 0 over 0. We need to find the factor that is making it the numerator and denominator 0, cancel them out, and then calculate the limit. So what I can do is that I can write x raised to the power 4 minus 81. I can write it as x raised to the power 2 whole squared minus 9 squared. Minus 9 squared, which is the same thing as basically a squared minus b squared, which is equal to a minus b times a plus b. So I can write as x squared minus 9 over x times x plus 9. X squared plus 9. That is about this part. And then this thing over here, this polynomial 2x squared minus 5x minus 3, you can write it as, so 3 times 2 is equal to 6. 6 is the same thing as 2 times 3. So if I write this as negative 2 and negative 3, negative 2 times negative 3 is equal to negative 2 times negative 3 is equal to positive 6, but here the problem is that we have negative 6. So what's the problem? So we have 2x squared minus 5x plus 3. Okay, so let me see how we can solve this problem. Okay, to solve this problem, what you can do is that you can write 6 as 1 times 6, and then make one of them negative and make one of them positive, meaning that you can write this as negative 6 and positive 1. Then 1 times negative 6 is equal to negative 6, which is basically these two numbers multiplied together. And then negative 6 plus 1 is equal to negative 5. So I write this as 2x squared minus 6x plus x minus 3. And then between these two I take a 2x out. I get x minus 3 plus 1 times x minus 3. And then you have 2x plus 1 times x minus 3. So this is going to be your denominator. And the numerator is basically this thing over here. Now, what you need to do with the numerator, you can leave this part as it is, that's not a problem. But you can write this part as x squared minus 3 squared times x squared plus 9. And then this is again the same thing as a squared minus b squared, which is equal to a minus b times a plus b. So you can write this as x minus 3 times x plus 3 times x squared plus 9. So then this is going to be your numerator. So then you can write this as the limit of x minus 3 times x plus 3 times x squared plus 9 over 2x plus 1 times x minus 3. And then what you can do is that as x tends to 3. Now since as x is not equal to 3, you can cancel these two out, and then you will get the limit of x plus 3 times x squared plus 9 over 2x plus 1 as x tends to 3, and that is equal to basically then 6 times 9 plus 9 over 2 times 3 plus 1, which is equal to 6 times 18 over 6 plus 1 is equal to 7, and 6 times 18 is equal to 18 times 6 is equal to 48, 108 over 7. You have 108 over 7. That's the limit of this function at that point. So number 8 is 108 over 7. Number 9 is another question. You want to find the limit of ax plus b over cx plus 1 as x tends to 0. But as x tends to 0, you can write this as well, a times 0 plus b, c times 0 plus 1, which is equal to b. Simple as that. 9 is B. Number 10. Number 10, you have the limit of z cubed minus 1 over z raised to the power 1/6 minus 1 as z tends to 1. Okay, so this one over here, we said that basically the limit of x raised to the power n minus a raised to the power n over x minus a when x tends to a is equal to n times a raised to the power n minus 1. So you can basically make some changes to this in order to rewrite it this way. And the way that you can do it, you can write it as the limit of okay, so now what you can do is that you can write basically this limit, you can write it as the limit of basically z cubed minus 1 over z minus 1 over z minus 1. The denominator, you can write it as z raised to the power 1/6 minus 1 over z minus 1. So I have divided both the numerator and denominator by z minus 1. So I haven't basically changed anything. I haven't changed the value of this function. And so you want to take the limit of this as z tends to 1. And of course I can write 1 and 1 cube would be the same thing, and 1 and 1 raised to the power 1/6 would be the same thing. So now I can write this as the limit, I can write this as the limit of z cubed minus 1 cube over z minus 1 as z tends to 1 over the limit of z raised to the power 1/6 minus 1 raised to the power 1/6 over z minus 1 as z tends to 1. And then you can write this as, you can use this to evaluate the numerator and the denominator, meaning that you can write this as z n times a raised to the power n minus 1, so 3 times 1 raised to the power 2 over 1/6 times 1 raised to the power basically 1/6 times 1 raised to the power 1/6 minus 1. Now this is 3 over 1/6, which is equal to 3 times 6, which is equal to 18. So number 10 is I must have made a mistake somewhere. N times a raised to the power n minus 1. See, I made a mistake. Well, I don't think the answer that we've gotten here is wrong or anything, but it seems that the question has been written. Oh no, it's not wrong. The question, I read the question wrong because the page was a little bit too, basically too high. I mean, it was the top of the question was hiding there actually. But this is not, I mean, basically this is not wrong, but this is not what we were supposed to solve actually. So I will do the question again. So it is the limit of, so this you can basically think of this as another question. So you have the limit of z raised to the power 1/3 minus 1 over z raised to the power 1/6 minus 1 when z tends to 1. Now, of course, you can basically write this as a limit of basically z raised to the power 1/3 minus 1 over z minus 1, and here you can write z raised to the power 1/6 minus 1 over z raised to z minus 1, and then you can write this as z tends to 1, and then basically write this as the limit of z raised to the power 1/3 minus 1 over z minus 1 as z tends to 1, and of course if you evaluate this at 1, you will get a 0 by 0. So you already know that. So, and then the denominator, you can write it as the limit of z raised to the power 1/6 minus 1 over z raised to the power z minus 1 as z tends to 1. And then you can write this as, basically, you know that the limit of x raised to the power n minus a raised to the power n over x minus a is when x tends to a, that is equal to n times a raised to the power n minus 1. So this is going to be equal to 1/3 into 1 raised to the power 1/3 minus 1, and the denominator becomes 1/6 into 1 raised to the power 1/6 minus 1, and that is equal to 1/3 over 1/6, which is equal to 1/3 times 6, which is equal to 2. Okay, that way you can solve the problem, and the answer is 2. Otherwise, what you can do, I would say better way of solving the same problem, you could basically write the problem as the limit of z raised to the power 1/3 minus 1 over z raised to the power 1/6 minus 1 as z tends to 1. You can take basically z raised to the power 1/6 as y. If you take this as y, then as z tends to 1, then y tends to, of course, tends to 1. So as z tends to 1, then this becomes basically something like for example, 1 raised to the power 1/6, which is equal to 1. So y So y tends to 1. So then you can write this as the limit of basically z raised to the, now if z raised to the power 1/6 is equal to y, this is z raised to the power 1/6. This is equal to y. Now if you have z raised to the power 1/3, you can write this as z raised to the power 2/6. 2/6 is 1/3, which is the same thing as z raised to the power 1/6 whole squared, which is the same thing as y squared, as you can see over here. So z raised to the power 1/3, I can write it as y squared. Y squared minus 1 over y minus 1, as y tends to 1, and then you can use the same thing that we had before. The limit of x raised to the power n minus a raised to the power n over x minus a as x tends to a is equal to n times a raised to the power n minus 1, and then you can write this as basically 2 into 1 raised to the power 2 minus 1, which is equal to 2, the same answer. But this is a little bit neater and cleaner than what I did before. Although it's not sometimes easy to see, for example, that if you take, for example, 0 raised to the power 1/6 as y, then this becomes, for example, y squared. That is also there. But if you can see these traits in numbers and in variables, well enough that you can, for example, recognize this, then of course this is a better way of solving the same problem. Otherwise, when I wanted to solve the problem, I really didn't see that, so I started dividing the numerator and denominator by some common factor. Okay, so the next question is the limit of ax squared plus bx plus c, ax squared plus bx plus c over cx squared plus bx plus a as x tends to 1, and here we have a plus b plus c is not equal to 0. So this is something like a general thing that you can use in many different situations if you happen to come across that. So now let's see how we can solve this problem. If a plus b plus c is not equal to 0, then that means that, well, you just simply evaluate the numerator and denominator at x is equal to 1. You would get basically a times 1 plus b times 1 plus c over c times 1 plus b times 1 plus a, and since a plus b plus c is not equal to 0, which means that the denominator is not equal to 0, this is equal to 1. This is equal to 1. Now suppose that you have the same thing. Suppose that you have the same thing, for example, the limit of ax squared plus bx plus c over cx squared plus bx plus a, and you want to take the limit of this as x, for example, tends to 2. And the same thing again, if Suppose that, for example, now let's see what happens here. This will give you basically a times 2 squared is equal to 4 plus 2b plus c. So, and this is basically 4 times c plus 2 times b plus 2 plus a No, it doesn't work here. Only if x tends to 1 will you get a 1. Otherwise you will get this expression over here which is not really useful. So the answer is 1. So question number 12 is the limit of 1 over x plus 1/2 over x plus 2 as x tends to negative 2. So here you will get 0, and here you will get a negative 1/2 plus 1/2, 0 over 0. Now here you can somehow use that substitution, meaning that you can use most probably you should use the substitution method, and also you need to most probably use this limit of x raised to the power n minus a raised to the power n over x minus a, as x tends to a is equal to n times a raised to the power n minus 1. You need to use this thing over here. And the way that we can do this is that if I set x is equal to y, then 1 over x would be 1 over y, which is equal to y raised to the power negative 1. And we said that here n has to be a positive. I think over here we said that n has to be a positive integer, or a positive, basically real number. We said that it could be a fraction even, but I think it cannot be negative, meaning that if I set x is equal to y here, then 1 over x becomes y raised to the power negative 1. And let me take a look at that thing over there. If any rational number for any positive integer, n has to be a positive number. So I cannot do this substitution. If I do this substitution, then this is not going to work for me. So what I'm going to do is set x 1 over x. If I set 1 over x is equal to y, then if I set 1 over x is equal to y, then then the numerator becomes y plus 1/2. 1/2. And then over here x would be 1 over y. And then over here x would be 1 over y. Or y raised to the power negative 1. Let's see. Okay, so it seems that there is a much easier way to solve this problem. You don't really need to do all of this thing, because I tried many different ways, or at least all the different ways possible. It was not possible to do it. So now if you set, basically we evaluated the numerator and denominator at x is equal to negative 2, and we got 0 by 0. So now what you can do is that you can write this as the limit of basically 2x. Take the LCM of 2 and x, and then you'll get 2 plus x over x plus 2 as x tends to negative 2. Now you can simplify basically 2 plus x over 2x times 1 over x plus 2. You can simplify these two and you'll get 1 over 2x. So you get the limit of 1 over 2x as x tends to negative 2. And so that will give you basically 1 over negative 4. Negative 1/4. I suppose the answer is negative 1/4. Okay. Number 13. Number 13 is the limit of sine ax over bx as x tends to 0. You have the limit of sine ax over bx as x tends to 0. So so here we have basically the limit of sine x by x as x tends to 0 is equal to 1. We had this limit. Now, so I can rewrite this as the limit of sine x. Okay, so you see that over here I have basically this ax is a part of the angle. This a is a part of the angle, meaning that I cannot write this as, for example, the limit of sine x, for example, times a. That I cannot do. So what I need to do, I need to write this as sine ax. Of course, I need the same angle over here, which is ax. And so I have a b over here times b, and then since I multiplied some a over here, I have to multiply it by the numerator as well. So I write it times a over here in the numerator. And as x tends to 0, and then I can write this as the limit of basically as the limit of a to b times sine ax to ax as x tends to 0. and then I can write this as the limit of, and so basically this a to b is basically some constant. I can take it out. A to b, the limit of sine ax by ax as x tends to 0, and well, this is basically equal to 1, because you can set ax is equal to y, for example, and so this becomes now as x tends to 0, y tends to 0. As x tends to 0, y tends to 0. So then that would be, for example, a to b, the limit of y tends to 0 of, for example, sine y to y, and then this becomes a 1, and so you'll get a divided by b. So that's a divided by b. Number 13, a divided by b. Number 14, you have the limit of sine ax by sine bx as x tends to 0, and a and b are not equal to 0. A and b are not equal to 0. So I can write this as the limit of, of course, here you will get if I set x is equal to 0 here, I'll get 0 to 0, which is not what I want. So I can write this as the limit of sine ax divided by ax and sine bx divided by bx, and then I have to multiply this by the reciprocal of this, which is bx to ax. X and x cancels out. You'll be left with b to a. And as x tends to 0 here, and then you will have the limit of, and then you will have, basically you can take this out, b to a, limit of b to a, the limit of sine ax to ax, sine bx to bx when x tends to 0, which is the same thing as b to a times the limit of sine ax to ax as x tends to 0 over the limit of sine bx to bx as x tends to 0, and of course you know that this is equal to 1, this is equal to 1, so these two will be just 1 to 1, and so you'll get b to a. So number 14 is might have made a mistake over here. Might have made a mistake over here, because I have divided the numerator So over here I have 1 over, let's just take this as just 1. So 1 over a to x divided by basically 1 over b to x. This is the same thing as 1 over 8x times bx, which is the same thing as bx to ax. So these two are cancelling out, and so what that means is that I have a b to a in this part of the fraction. Since I have a b to a, I have to multiply it by a to b. So I delete this, erase this. So since here I have a b to a, I can simply write here a to b, and then those two will be cancelled out, meaning that now everything is just the same as it was basically when we had this fraction. We have just added these over here, and then we have taken them out. So then this becomes basically a to b, and a to b. So a to b, and a to b, and that is the right answer. I made a mistake over here when I didn't write that right. Number 15 is the limit of sine pi minus x over pi times pi minus x. Pi times pi minus x as x tends to pi. So as x tends to pi, this becomes 0. And then over here, you have sine 0 is equal to 0, you get 0 to 0. Now what I need to do, we said that the limit of sine x to x as x tends to 0 is equal to 1. So I write this as the limit of basically sine pi minus x over pi minus x. Let's see. Oh, pi minus x, I already have it over here. I don't have to write this thing. So pi minus x is over here. So if I write this as simply as the limit of sine of pi minus x over pi minus x times 1 over pi, then I can, as x tends to pi, I can just simply take this out, 1 over pi, take it out, and write it as the limit of pi minus x over pi minus x as x tends to pi, which is going to be equal to 1 over pi because this part is 0. I'm sorry, this part is 1. So number 15 is 1 over pi. Number 16 is the limit of cos x, over pi minus x as x tends to 0. Okay. So basically we said that the limit of 1 minus cos x over I think it was over x as x tends to 0 was equal to, I don't remember that. Let's see. 1 minus cos x over x as x tends to 0 is equal to 0. So well, actually I forgot to evaluate the rational function at 0. So cos 0 is equal to 1. Cos 0 is equal to 1. And pi minus 0 is basically, well, pi. So this is 1 over pi. This is 1 over pi.